Okay, hello everyone in a new video, and so we have reached part 2 of chapter 5, which is the chapter of generators and receivers for grade 10 students. So now in this one we are going to solve some exercises on what we have explained so far in part 1. Now exercise number 2, they are telling us the voltage across the terminals of two electric dipoles, D1 and D2 are, so we have the voltage U1 and the voltage U2. Now in number 1, they are telling me to specify the nature of D1 and D2. And so what do we mean by dipole? An electric component that have two terminals. So we restrict, so we are only interested in three natures of dipoles. They are given by resistors, generators, or receivers. And this can be done which is specifying the nature of each one by comparing the given form with Ohm's law. We know that the three different laws that we have discussed, which are Ohm's law, are given by U is equal to R multiplied by I, U is equal to E plus IR, let me say Ri, and U is equal to E minus Ri. So if the coefficient is plus, then this is a receiver. If the coefficient is minus, this is a generator. And if it's there is only I, the linear term, there is no constant, this is a pure resistor. Okay, so let's start by the nature of D1. So let me say that since U1 is equal to minus 0.5I plus 6, so here we have a minus sign, verifies the general form. Which is given by U is equal to E minus Ri. Then here we need to mention the law that we have referred to in order to write this equation. Then according to Ohm's law, D1 is a generator. Let me start by the nature of D2. So now notice that both have the same sign, which is plus or minus. Then in this case, the nature of D2 is a receiver. Now since U2 is equal to 2I plus 4, verifies the general form which is given by U is equal to E plus Ri. Then D2 is a receiver. Now why specifying the nature of each electric component is important? Because this allows us to determine its characteristics. And without no exception here they are asking us to determine the characteristics of D1 and D2. So let's start by the characteristics of D1. And so we know that each receiver is characterized, so D1, because it's a generator, it's characterized by two characteristics or two parameters given by E and R, in which E represents the electromotive force and R is the internal resistance. Now the electromotive force is the maximum voltage supplied by the generator with no current. As for D2, which is given by E and R, so E would be the back electromotive force, R is the internal resistance. E is the back electromotive force, which means the minimum voltage needed for this electric component to start to operate. So here let me say that this is prime and this is prime to distinguish between E prime and R prime from E and R. Now let's start with the characteristics of D1, and this is done by comparing this form with this form, and the characteristics are E and R. So we have that U 1 is equal to minus 0.5 I plus 6, and on the other side U1 can be written as E minus Ri because this is a generator. Then now by comparison, so comparing the linear term, or let's start by comparing the constants. So the electromotive force is given by 6 volts, and now comparing the linear term, we can see that the coefficient of I in both cases is minus R, which is equal to minus 0.5. Minus cancel out with minus, so R is equal to 0.5 ohms because the internal resistance is always positive. Now as for the characteristics of D2, we know that the given form is given by U2 is equal to 2I plus 4. And the general form that we are referring to is given by E prime plus R prime I. So in this case, by comparison, we can say that the characteristics of D2 are given by E prime is equal to, so comparing the constant, this is equal to 4. And comparing the current, R prime would be given to 2. And everything is expressed in that size, so the value of the internal resistance is given by 2 ohms. Now as for number 3, they are telling us D2 is connected to D1 by connecting wires. Let's do so. So this is the electric component D1 connected to D2 by connecting wires. This is D1 and this is D2. Now simply because we know that D1 is a receiver, let's use the convenience symbol, which is the symbol of a generator, which is this one. So here I'm supposing that the generator is a DC generator. Now calculate the intensity of the current traversing the circuit. We need to determine the value of I. So in such type of exercises or questions in generators and receiver, the way that we proceed is either we apply the law of addition of voltages or law of uniqueness of voltages, then apply Ohm's law, then solve for I. So now because they are connected in parallel, or they are the only two electric components in the circuit, they share the same voltage. So we can say that D1 and D2 are in parallel. Then according to law of uniqueness of voltages, they have the same voltage. So in this case, the voltage U1 is equal to the voltage U2. Okay, so in this case U1 is given by minus 0.5 I plus 6, and the voltage U2 is given by 2I plus 4. So first we applied the law of uniqueness of voltages, then now in this case we applied Ohm's law. Now we are solving for the value of I. How to solve this equation? This is a linear equation and one unknown. We put I on one side and all the others on the other side. So minus 0.5 I minus 2I, dragging 2 to the left hand side, which is equal to, now dragging 6 to the right hand side, this will be minus 6 plus 4. So minus 2.5 I, which is equal to minus 2. Now how do you solve it? For I, we divide both sides by the coefficient of I, which is given by minus 2.5. So I in this case is given by minus 2 divided by minus 2.5, which is equal to 2 divided by 2.5. Plugging this on the calculator, then the value of I would be given by 0.8. Everything is expressed in that side, so the value of I will be in that side, which is amperes. So this is it for exercise number 2. Now let's move on to exercise number 3. So here we'll follow the same procedure. Now they are telling us a circuit contains a generator G 16 volts 2 ohms, a motor amp 8 volts 5 ohms. So let me write them here. The generator G, which is given by ER, we have that E is equal to 16 volts and R is equal to 2 ohms. So here what I have done is I have directly identified the values of E and R by comparing this with that. Now the same for the motor. Now we have that the motor is characterized by the back electromotive force and the small internal resistance R prime. So we have that the back electromotive force E is given by 8 volts from here, and the value of the internal resistance is given by 5 ohms. Okay. Now recall that this is a generator because it's mentioned so, and we know that the motor is a receiver. It transforms electric energy into mechanical. Now R1 is given by 6 ohms, R2 is equal to 3 ohms, and R3 is equal to 2 ohms. So the trick in solving such type of exercises is to write only the applied voltage, supplied voltage, and the value of the electric current on the circuit itself. Notice that in this case I didn't label the electromotive force to be here, and I didn't label the back electromotive force to be across the motors here because they don't represent. So here we cannot say that UPN is equal to 16 volts. This is completely wrong, and we cannot say that UBC is equal to 8 volts. This is completely wrong because the voltages UPN and UBC are governed using Ohm's law. Okay. Now number 1, they are telling me to calculate the equivalent resistance of the 3 resistors in the circuit. So the 3 resistors in the circuit, they are talking about R1, R2, and R3. Although we have another internal resistance here and here, but we are only concerned about these, and they are connected in parallel. Then let me mention that R1, R2, and R3 are in parallel. So this statement, they usually give it half a mark. So in this case, the equivalent resistance is given by 1 over R equivalent, which is equal to 1 over R1 plus 1 over R2 plus 1 over R3, which is equal to 1 over 6 plus 1 over 3 plus 1 over 2. So the sum of the reciprocals. Plugging this on the calculator, eventually you find that the sum of these fractions, after taking into consideration the common denominator, is given by 1 over 1. So 1 over R equivalent is equal to 1 over 1. Now if you cross multiply, then the value of R equivalent is given by 1 ohms. And the trick in solving such type of exercises, whenever we calculate an equivalent resistance, we replace this equivalent resistance in the circuit. So here we have the generator. From P to A, from A to B, it's being replaced by R equivalent, which is equal to 1 ohms. The motor amp, and from C of the motor back to N of the battery. So now what do we expect? We expect that we should apply the law of additional voltages, then apply Ohm's law to determine the value of the current, then determine the voltage across all electric components. Let me make some space here. And indeed here they are telling us a number to determine the intensity of the main current in the circuit. This is done by applying the law of additional voltages. So apply law of addition of voltages. So usually how to apply this law? Always on the left we write the voltage that you are interested in calculating, and on the other side all the voltages across different electric components, respecting the fact that we go from a point and move to another point. If we start with P, we should start on the right hand side with P. If we ended with N, then we also on the other side we must end with N. Now the other version also, that on the left hand side we write the voltage of the battery, and on the other side we move across different electric components. Since here we are interested in determining the value of the current, so we'll use this version, which is on the left hand side we write the voltage of the battery, which is given by UPN, and on the other hand side we'll go from P to A plus from A to B, B to C, C to N. Now how come we are interested in determining the main current but we have applied the law of addition of voltages? The thing is that all of these voltages can be transformed into currents by applying Ohm's law, respecting the nature of each electric component. Let's start by UPN, and here let me specify the direction of the current, which is like this. Now recall that this component is a generator, and Ohm's law for a generator, it is either given by E minus IR, or, so here, or minus E minus IR, and this minus sign depends whether we are moving in the correct direction of the current or not. Since it's a generator, we should oppose the direction of the current. So in this case, the plus sign would be from P to N, and we are moving, if in the direction of the current, it would be the minus sign. So since this voltage UPN, so I repeat, why we are choosing this one, the first and not the second. We use the first in the case of a generator if we are moving in opposite to the direction of the current, and we choose the minus sign if we are moving in the direction of the current because this is a generator. Okay, so we'll choose the first one, which is E minus IR. Why? Simply because this is a generator and we are moving opposite to the direction of the current. So here between brackets we need to mention Ohm's law for a generator. Now as for UPA, this would be 0 because it's a connecting wire. As for UAB, so across A and B we have R equivalent, so this is a pure resistor which is given by R equivalent. So I would rather always write the resistance than the current. R equivalent, but it's the same. So Ohm's law for a pure resistor. Now as for the voltage UBC, this is a receiver, so the voltage should be given by either. So here it's denoted by E and small r prime. So it would be either given by UBC is equal to E plus r prime multiplied by I, or UBC is given by minus E plus r prime I, and this depends whether we are moving in the direction of the current or opposite to the direction of the current. Because this is a receiver, we need to move in the direction of the current. So I repeat, because, so when do we choose this one, the positive? If we are moving in the direction of the current, because this is a receiver, so we'll choose this one. However, if we are considering the voltage UCB and this is a receiver and we are moving in the direction opposite to the current, then it would be the minus sign. Okay, so this is exactly opposite to the generator. So let me repeat. Here we have two forms of the voltage UBC across this receiver, and they are given by E plus R prime multiplied by I and E plus R prime multiplied by I multiplied by minus sign. Because we will choose, when do we choose the first one? If you are moving in the direction of the current, because this is a receiver. Since UBC is in the direction of the current from B to C, then we will choose this one. Now similarly for the pure resistor, I didn't discuss this. Let me write here Ohm's law for a receiver. So for this resistor, we have that UAB would be given by R equivalent multiplied by I, or UAB is equal to minus R equivalent multiplied by I. So which one do we choose? Because the resistor is a special case of a receiver, so we will choose this one if we are moving in the direction of the current, and indeed because from A to B we are moving in the direction of the current, then we choose UAB is equal to R equivalent multiplied by I and not this one. And finally, as for the voltage UCN, this is equal to 0, and the reason is given by connecting wire. So now what we will do is that we replace all of these expressions in this equation and we solve for I. So instead of UPN, we will replace this one, which is given by E minus Ri. Instead of UPA, we will replace 0. Instead of UAB, we will replace R equivalent multiplied by I. Instead of UBC, I will replace E plus R prime multiplied by I, and instead of UCN, we replace 0. Now let me replace the values of E, R equivalent, small e, and R prime. The capital E is given by 16. Small r is given by 2. R equivalent is given by 1. I is I. Small e is given by 8. R prime is given by 5 multiplied by I. So here we have that 16 minus 2i is equal to I plus 8 plus 5i. What's the type of this equation? This is a linear equation and the unknown is given by I. How do we solve it? We put I on one side and all the others on the other side. So minus 2i minus I minus 5i. Now dragging 16 to the right hand side, it will be 8 minus 16. So minus 2 minus 1 minus 5, this would be minus 8i, which is equal to minus 8. Now what would be the value of I? So divide both sides by minus 8. This cancels out with this. So I would be given by minus 8 divided by minus 8. So this is equal to 1. Everything is expressed in that SI. So the value of I would be 1 amperes. Now let me label this current here. Now on number 3, they are telling me to calculate the voltage UPN. Let me do it here. So we are asked to calculate the voltages UPN, UAB, and UBC. And this is straightforward now because we know the value of the currents. So now UPN is already given here, which is given by E minus Ri. Now the value of E is given by 16. The value of small r is given by 2. And the value of I that we have determined is given by 1. No need to mention any law because we have already done so. So 16 minus 2, this is equal to 14 volts. Everything is expressed in SI. Now as for the voltage UAB, this is given by R equivalent multiplied by I. R equivalent is set to be 1 and I is 1, so this is equal to 1 volts. And as for the voltage UBC, this is given by E plus R prime I. The value of a small e is given by 8 and the internal resistance is given by 5. The value of the current is 1, so this is equal to 13 volts. And as you can see, so now in this case we can write that the voltage UPN is equal to 14 volts and the voltage UAB is equal to 1 volts and the voltage UBC is equal to 13 volts. For this reason we haven't labeled these voltages on the electric circuits, on the electric component, on the electric circuit itself, and we have rather labeled the applied voltages here. Okay, so this is important. So that's it for me in this video, guys. In the next part we'll continue solving exercise on this chapter and complete the explanation.